Hey guys, let's see. Last time, remember we had, let's remember, three sorts of row operations. Row operation. Can you turn off your microphone, please? Who is that? Okay. Microphone. I can see. Okay, thanks. Now, first one was, so when you have a matrix A, let's write this as column, rows, row 1, row 2, row M. So that means each Ri is a matrix, something like this, right? So 1 by n matrix. Each Ri is a 1 by n matrix, and the row operations were was that. So if you multiply row I by some constant, and then add it to the jth row, and you don't change others. That is the so it changes A2. So if you write it like this, it change A2 into this matrix R1 and RA. Instead of RJ, we have C times RI plus RJ, and etc. And the second type of operation was that you interchange two rows. So you interchange I and j row. And thirdly is that you multiply a row by a constant. So instead of Ri, you write C times Ri. Well, let me questions. Zoom time. How do I turn this off? Okay, let's see. So somebody asked me this last time, why do we do these operations? Let me give an example. So I prepared some example. And so here's an example that we will see later. Let's try to solve this equation. Solve this system of equation x plus 2y is equal to 1, for example, and minus 2x plus 3y is equal to minus 1. Let's try to solve this equation. So this is a smaller equation, but we will do it in a systematical way so that it will, for larger, so more same method will work with this method. The same method will work. So if you say this matrix A as 1, 2, minus 2, 3, these are the coefficients, 1, 2, minus 2, and 3. And let's say if B is the other side, x minus, so oops, not x, this is 1. 1 minus 1. Then we can write the system as like this. 1, 2, minus 2, 3 times xy is equal to 1 minus 1, right? We want to solve this equation. So let's do it. As I said, we will see this later in detail. So let's write this into in this form, minus 2, 3. And let's write this 1 minus 1 here. The reason is that, for example, if you multiply this equation by 5 both sides, that means you are multiplying this row by 5. We don't have a WhatsApp group yet. Are you asking me? I don't know. Okay, so this corresponds to this. This matrix corresponds to x plus 2y is equal to 1 and minus 2x plus 3y is equal to minus 1. Now, if you, for example, if you multiply the first equation by 2, so 2 times R1 plus R2. So what do? We multiply this. Let's multiply this first equation by 2 and add it to the second one. So then we get x plus 2y is equal to 1. And here, 0 times x, let me write like this, plus 7 times y is equal to, when you multiply by 2, you get 1. But here, this is exactly the same thing as the first row stays the same, and second row, this becomes 0. That is, you multiply this by 2 and add it to the second row, you get 1. Okay? So this is this matrix corresponds to that system. Now you can solve that system, of course, but let's continue this with this. Let's continue with this. So if you, what can we do now? Let's multiply this. Multiply the second row. So let's go this way. Second row by 1 over 7 R2. So that 0, 1. Second row, you multiply by 1 over 7. Here is that the first equation stays the same, and you divide the second equation by 7. Okay? Of course, you can solve it from here, but let's continue a little bit more. What else can we do? Well, we can multiply. So this matrix is now row reduced. Not row reduced. It's an echelon form, but it's not row reduced yet. In order to get row reduced matrix, this 2 must be 0. The 2 must turn into 0. So in this equation, if you multiply the second equation by -2 and add the first equation, what do we get? If you multiply the second equation by -2 and add the first equation, it is x is equal to 1 minus 2 over 7. And y is, which is, what is 5 over 7. And y is 1 over 7. So the solution becomes 5 over 7, 1 over 7. Here, it becomes 1. In order to, you multiply this row by -2. Did we multiply by -2? Yes. You multiply the second row by -2, row 2 by -2, and add it to first row. Then this becomes 0, -2 plus -2 over 7 plus 1 is 5 over 7. 5 over 7. This is 0, 1. This is 1 over 7. So this matrix corresponds to that system. So instead of writing the system all the time, we will just play with this matrix, and at the end we will get a solution. So 1 times x is equal to 5 over 7, and 0 times x plus 1 times y is equal to 1 over 7 is equivalent to the original system. So their solutions are the same. So that's why this finding echelon matrix and row reduced echelon matrix are important. So for this, we had a lemma above at the end of last lecture, namely, so we had the definition that elementary matrix. What's an elementary matrix? Remember, elementary matrix. An elementary matrix is a matrix obtained from the identity by a single row operation. So if epsilon is a row operation, then it's an elementary matrix. Just apply epsilon to identity matrix. This is the identity matrix. So for example, in the above example, let's see. In the above example, we had this matrix. We can also write it like this. Let's say this, we have this matrix A as 1, 2. Let's write matrix A. This is another matrix as 1, 2, 1, and -2, 3, -1. Suppose we have this matrix. Then what did we have? Well, first we applied our first operation was, our first operation above is 2R1 plus R2. That is 2R1 plus R2. So that if we apply this, remember identity matrix 2 by 2 identity matrix is 1, 0, 0, 1. When you apply this epsilon 1 to the identity matrix, what do we have? 1, 0, 2, 1. Okay, this is the first. Let's call this E1. Let's call this matrix E1. Now, what was the second row operation above? Well, this is the first row operation. Second row, this is the first. This is the second row operation. That's the third row operation, right? Second row operation is 1/2 R2. So in this identity matrix, multiply the second row by, let me write here, epsilon 2 identity is, if we multiply the second row by 1/7, we have 0, sorry, 1, 0, which is 1, 0, 0, 1/7. 1/7. And third row operation is -2 R2 plus R1. And that is -2 R2 plus R1 is when you apply, this is, let's say, E2, and epsilon 3, when you apply epsilon 3 to the identity matrix. So you multiply the second row by -2 and add the first row, 1, -2, 0, 1. So let's say this is epsilon 3, E3, so that we have this matrix. So we had this matrix A, we applied epsilon 1, and then epsilon 2, and then epsilon 3, right? That at the end, we got this matrix. Let's call this matrix B. We got the matrix B above B. Let me write like this. That this is 1, 0, 0, 1. And 5/7, 1/7. Why? I cannot write. Okay, 5/7, 1/7. I guess my pen is I need to charge the pen. Anyway, just a second. I forgot to charge the pen, so that let's see, does it right now? No. Anyway, let me. This is another problem. What should I do? What do we do now? And does not work anymore. Okay, let's see. Let me write then in this case.
Hocam bir şey soracağım. Chat'ten konuştuk da ben tam anlayamadım. Yardımcı olursanız. İkinci işlemi yaptıktan sonra 1/7'nin yanında bir de 2/7 olmayacak mı? Orayı tam anlayamadım.
Bir dakika. Let me